Now I have many different forecasting results that's under many different forecasting techniques, starting from naive, and then moving average, weighted moving average, and then I have exponential smoothing, many different alpha values under exponential smoothing, and then you have a trend projections. And how to determine which prediction method or forecasting techniques are best or best suited for your specific prediction purposes. Okay, so for that, we need to be able to measure the prediction accuracies using some of the measures, forecasting accuracy measures. So to demonstrate the concept, what I would do is I am going to just compare the prediction between the naive and 4 moving average. I want to compare 4 period moving average with a 2 period moving average. Okay, just to see which which period will give you a better forecasting result. So I'm going to insert 3 columns after each one of those techniques, because I'm going to create 3 columns for each. So if you look at this equation for the forecasting accuracy, first one is what's being referred to as a mean absolute deviation. Second one is essentially mean squared error. So I introduced some squared error just because mean squared error relies on sum of squared error. Okay, so with that, what I'm going to do is I'm going to do this first. I'm going to do absolute value between 1 minus y hat. As you may recall, hat refers to the prediction. Okay, this is going to be the first approach. The next approach is y minus y hat and the squared. So I think this will make it work. So I'm going to do exactly the same thing with this. And then I'm going to do average. No, I'm going to do total and average. Whatever that I'll be calculating here, I'll be getting the total, I'll be getting the average. Okay, so the idea is that because the way this is being set up to measure, you are actually adding together all the forecasting errors. Okay, so y minus y hat. So in this case, you're doing revenue, actual revenue minus forecasted revenue under 4 months moving average. So in this case, obviously you have D minus, in this case you have over forecasted your revenue, where your prediction is higher by 1506. So you do that, but but you're not just merely taking the differences. Okay, you'll be taking the absolute value of the differences. So in that way, everything in this column will be positive number. If you don't add absolute value in here, you will see that those numbers will start to cancel each other out, and resulting the sum will be actually, it cannot actually reflect the true measure for the forecasting accuracies because they're canceling with each other out. Okay, so this is sum, and you can add them up, and this is your total amount of deviation. But in here, we're going to have to do the average. Okay, we're going to have to do the average. This here, I didn't say this explicitly, but this is what you're seeing. What you're seeing here, this is a mean absolute deviation. This is one measure of forecasting accuracy. So this is what we did. For each pair, we took the difference, we applied absolute. We took absolute value, which have turned all those results as a positive, and then we divided by number of observations there, which essentially gave you the average. And this is one approach, MAD. And the other approach is your mean squared error. Okay, so essentially you also take difference, you also take the difference, but you have to square it. Okay, this is needed also to prevent that all the resulting differences canceling each other out. Okay, the total here is basically the sum of everything here, and average, you have to just average them out. Okay, average them. Though exactly same approach will be taken for these two columns as well. Okay, but before I move on, what's at the bottom is mean squared error, MSE. What's on top is sum of squared errors. Okay, they are all error measures. Average is more useful because in some cases you will be comparing different number of observations. As you can see here, you have a too short. Yeah, this 2-period moving average, you have like a 2 more observations. Therefore, it may be it's a sum squared error may be bigger than the 4-period. Just because there are more numbers here, not because it's delivering, poor forecasting performance. Okay, so again, we'll do ABS, the difference between the revenue and forecasted value. We take the absolute value here, and here is a difference between actual with forecasting, but you squared it. Okay, so I know you are getting a very large numbers, but this is a very, very realistic data because I actually pulled this from the Walmart's financial statement. Okay, so again, we're doing this one more time. Sum of everything here. Average here. Oops. Okay, so now you can compare which result is actually producing better predictions. Okay, as you can see that this is some interesting result. In general, the conclusion between the mean average deviation with the mean square error is somewhat consistent, meaning that if MAD is smaller here, we should also expect MSE is also smaller here. But in some in general, that's the case, but I cannot guarantee in every case you're seeing something like that. Okay, so this looks like it's one of the interesting or extraordinary cases where two are yielding a different result. Okay, so maybe just because they're different, they're telling different story, and I can maybe double check whether I did everything correct. Okay, so I don't think I did anything wrong. It just gave me a conflicting result. So what else I can try is I can try to remove those two observations to see whether the result is consistent. Okay, now as you can see that the prediction under 4-period is actually much better than prediction under 2-period, judging from the MAD and MSE. Now they're consistent. I think the inclusion of those leading 2 periods have somehow have complicated our conclusion, but I think this is more straightforward. Okay, so yeah, this is how the forecasting accuracy measure works. So in general, you want to have as little deviation as possible, because the forecasting accuracy measure always use the difference between actual and the forecasted as the basis. Okay, so I think that's everything that you need to do over Excel in this particular chapter.